and answer this kind of question. Practice quiz question. This is an example of something more involved. You'll have to write out some lines of code. Not very much, but it's the more coding-based question. Write a Python expression for the distance formula like this. And I'll give you some points. And then all we need to do is translate this mumbo jumbo into Python. And then I will also address this challenge where we write a function that does this for us. At the end of this lecture, we should feel confident on where this comes from. And maybe I won't give you as complicated an expression, but expect to see something like this on your quiz Friday. All right, so I'm going to pull up Trinket. It looks like this. And this first part, I want to highlight some features of Trinket. Here is your project title. This will be block 6, lecture number 2, demo. You press enter and it'll save. Some other features I want to highlight on Trinket is that here you have a menu. This is a hamburger menu. What do you all call this little stacky thing? Files, settings, or something?
3 bars.
Yeah, the 3 bars. So it's funny, my friend used to work for HP, and there are a bunch of old, seasoned veteran coders there. Imagine like your parents and older. And they were before the time of mobile devices where these 3 bars was really common. So they're always looking for like a file or something like settings. And so to describe this to them, because they didn't know that this is now the menu or the settings or the 3 bars, he had to come up with a phrase. And he has coined the phrase, this is a hamburger, because you got 2 buns and the meat inside. Click on the patty menu. And those old people know how to, experienced coders then knew where to go. Yes. So some useful features over here. You can change text size. It's a limited editor. It doesn't do it does do some auto completion, but this is how you change text size. You press save. You'll notice that it doesn't automatically save for you as often as you would like to. So click this save button often if you want to save your progress, not just at the end of class. Let's see. Other useful functions. There are 2 windows here. One is the result, your output. Instructions tells people how to use your code. For example, something more involved that uses mouse input or arrow keys, you would put that instruction here. If you were with me last semester, this is like writing the HTML out that tells me how to play your like Pong game, for example. Other things that are useful is the console, and that'll be the main focus of my lecture, is using this console here. Trinket allows us to have this interactive console, which is a feature of Python. You can interact with code and play around with the interpreter and make it run code and little lines all in this console window. And you should be familiar with run. It runs whatever program you have written here, and that's how you get your pretty pictures. And yeah, those are 2 things. So I will make my text large, and thus begins some talking at you. To review, the first lecture I talked about data types. We were using the type function. We were using the type function, and then investigating. 1 is of type integer. It's different than, let's say, 1.0, which is a decimal. Decimals are real numbers. They're called floats, floating point numbers. It's what it's short for. That also applies to rational numbers like 1/2. This is of type float. These should look familiar from math class. Other types, you have, So notice when I typed in here, and then I just typed in the character A. This one, it says it's a name error. A is not defined at unknown. So usually it would try to reference a line number here, but since I'm using the interactive console, it doesn't know what line number. So this is a name error because right now Python is thinking this is a variable, A, that I've defined it somewhere. So it goes searching through like the top of the code that has been run, and it doesn't know what A is. So if we haven't defined A, Python will spit out an error. Notice here that I'm typing type, and then I put quotation marks up. This one, Python does know what it is. It is of type string. str stands for string. It's a string or a sequence of characters. Let's see, other types. The single character A is also of type string. Another useful one that we've seen a little bit of is a list. 1, 2, 3, 4. we call them arrays in Java and JavaScript. Python calls them lists. 1, 2, 3, 4, class list. You need to know that there are different data types, and although in this class we won't be exploring why that is, know that your computer stores these things differently. If you want to talk about efficiency, if you want to talk about how the hardware and actual memory, how the computer stores it and reads it, then you'll need to know the specifics of why these different data types exist, but not for this class. Okay, now, our good old friend, variables and the assignment operator. What do I mean by that? So far, remember that A we talked about before? Since A by itself is a variable, let's assign it a value. I'll give it 1, 2, 3 as its value. Press enter in the console. And if I press A and I press enter again, I see the number I gave it, 1, 2, 3. The equal sign is a special, it's an operator. So the left-hand side has significance and the right-hand side has significance. It doesn't work like it does in math. For example, if I say now A is 12, what do you think A is? Yep, 12. And if I say A equals, let's say 1, 2, 3, 4, 5, 6, like that, with the little quotes, what do you think it is? Yep, 8. What do you think its type is? What's the type of A right now? Yep, str. So you can do these things, interact with it, kind of quiz yourself. But take a look at this. If I did 1, 2, 3, 4 equals A, what do you think is going to happen now? I switch the order. I have 1, 2, 3 on the left-hand side, and I have the variable A on the right-hand side. Think about it for a couple seconds. Give it a guess. Let's press enter. Compiler, tell us. Or interpreter, tell us. It gives us syntax error. Can't assign to a literal at unknown. So what's happening here? Left-hand side is a literal. It's like the small. It's a special. It's a value pretty much. It's something that already has meaning. 1, 2, 3. That's an integer. And then the right-hand side is your variable. The assignment operator, which we know as the equal sign in math, is, here's the kicker. Here's what's different. A, whatever's on the right-hand side, is stored into the left-hand side. And right now, A's value, last we checked, it was the string 1, 2, 3, 4, 5. But it cannot fit into something that already has value, 1, 2, 3. Let's say, for example, well, maybe it's because A already has a number and we're trying to squish something into there that's already filled. Well, let's go do, let's say, QWERTY equals X. I haven't used X just yet. Let's try this. Enter. Same thing. This will definitely be on your quiz. The assignment operator only gives what's on the right-hand side and stores it into the left-hand side. So this is not proper syntax. You can do it the opposite way. Maybe do it like this. Oops, sorry. I meant to type it with strings. Otherwise, it would think the QWERTY, the first couple keys in the keyboard, is an actual variable. Cool. You can store more complicated things. These are called expressions. It may look like we're just adding in some numbers, 1, 2, 3, 4, W, enter. A useful feature of the console, and later in the more advanced programming classes, you're going to see the command line. If you're used to Linux or the Windows command line tool or the terminal in macOS, then know that you can press up and down to go through whatever you typed last, the history. See, there's all the code that I typed into Interpreter since the beginning of class, starting with type 1. So if I'm lazy and I didn't want to retype like this line, then I would just press up a bunch of times and I'll get this. Let's check. Yeah, X is this one. More complicated expressions, like the distance formula, another part that it uses is the square root function. Looks like this. Square root 4. What is square root 4? Yep, we know it's 2. We press enter and it says, name error again. SQRT is not defined. Square root belongs to a library. Specifically, it's from the math library or the math module. That's just like the turtle module you used. And for assignment 2, that's just like the processing module that you use. Module library, very similar. So we have to go from math, import all those math functions. And now let's go back. I'm pressing up the up key twice. Let's now see square root of 2. Nice. There it is. Square root of 2 is the, well, let's check. What's the type? of square root of 4 to review data types. Is it an integer? You see a decimal point though, so it's a floating point number, float, and it confirms it for us. I can put functions into functions. You've been doing so in Turtle, you've been doing so while drawing shapes. You're calling these different functions inside the draw function. Here I'm calling and checking the square root on what data type it is by putting that inside of the type function. Okay. Other things that are different, you might have recognized that this symbol, we would read that as x squared sometimes if we type it into Google to figure that out, but that's not, that's a special character. Notice it says XOR. We'll talk about logic later. To do exponents, like 2 squared, you press the star twice. 2 to the 2 is how this is read in normal calculator speak, math speak, is 4. 2 to the third, double star, is 3. 3 squared is 2. And if normal multiplication is a singular star, that's 6. All right, that works. Questions so far? No. All right. Another thing to follow is that Python follows order of operations. We'll have this kind of subtraction. Let's see. Yeah. This is what we would normally type into math, but it doesn't recognize this shortcut. Like this is 4 times 1 minus 3, so we have to explicitly add in that star to do that multiplication. And if we do double star squared, this should abide by the order of operation. 1 minus 3 is 2. Square that, because that's in parentheses, gets us 4, and 4 times 4 is 16. Okay, it follows order of operations. These that I've typed in so far are called expressions, very similar to math expressions. And the last part is, how do I make my own functions? And that will get us closer to that challenge as I started at the beginning of the lecture. So you can define functions in the console, but it's a little tedious. What do I mean? For example, maybe we want to do raise something to the 4th power, right? I'll name it 4th, or 2 4th. And I'll do the special keyword def. I'll have no argument, so my parentheses are empty, and then I use a colon. Notice now, the interpreter, Python, is waiting for you to tell it, what does 2 4th mean? And, oh, sorry, I messed up. Let's do that one more time. So 2 4th, we need to give it a number. What are we raising to the 4th power? Call it x. What are we going to do with x? Well, let's return x times x times x times x. Enter. Enter twice. Let's see. 2 to the 4th power. So 2 4th of 2 gets us 16. 2 4th of 3 gets us to what? 81. Yes. Wait. Yeah. 9 times 9 is 81. Correct. Okay. So what just happened there? It becomes harder for us to retrace our steps, and because just pressing up and down gets a little tedious. That's why we have main.py over here. I'll retype out that function to 4th of x, and how do we do that? We return x times x times x times x, like that. We just made our own function. What does it do? It helps us multiply x by itself 4 times. We've made our own function. It takes in an input, as seen here, x. What does it do? It does this, and then return is a keyword that's like in math, your y, your output. It exits this function and then tells it, this is the number you want. Here it is. Here's the value to x times x times x times x. Questions? You could have also done print, for example, x times x times x times x. That would have shown the function out to your console. So let me run this so that now Python, the console knows to look for this. 2 4th And let's say give in 2/4, and then I put in the number 2. What do you think I'll see up on the screen? You're thinking 16? Then I ask you the follow-up question, is it 1/16 or 2/16? You're thinking, that's fine, let's see. Ooh. So one of these 16s came from line 2. You're telling it to go print to the console this value. The second one is something called the return value of this function. This is the output at the very end of your program. This is the value that's there. Why is this useful? Well, let's say we want to store that into a variable. Let's call this one z equals 2/4 of 2. The first 16 that came out was from print, and the other 16 is now stored into z. We'll test this out further. Let's comment that out. The hashtag is the comment symbol. If I made that change, I have to press run so Python knows to look for that. To bring up my console again, I'll go up to the left and I'll click on console. Yay, it's here. And we'll go once more. Oops. I want to 2/4, 2. 2/4, 2. There's our 16. And let's go type into W. Let's try to store in the value of 2. Enter. W. Ah, wait, what? Without that return value there, it has nothing to store. Its output has already finished. It's printed 16 to the screen, and it's done its job. So it just stops, and there's nothing to store into W. That's a newer idea that will come up later in your functions. And for the first couple of weeks, it's exploring what's possible with these functions. Let's go revisit. Oh, questions? If not, let's review. For this question here, we have as input 2 points, and we're going to punch this in to Python, and we're going to attempt the challenge at the same time. We're going to do square root, we're going to do some differences, and then we're going to square them and then return the distance, the final answer. That's like boxing your answer in math, pretty much, the return value. So def distance, it has now 4 inputs, 4 numbers, x1, y1, x2, y2, colon. So we're telling now Python, this is what it means to figure out this function distance. You are going to return the square root of x1 minus x2. All that will be squared. And I think it's adding, right? Yep, adding plus the same thing, except with the y coordinates. y1 minus y2, all in parentheses, squared. Let me see if I can do this and this. Drag this over, drag this over. So now in symbols and in Python code, we have something that now matches this one. Well, I guess if we want to match it exactly, the 2's go first, this goes here. But since we square it, it doesn't really matter. The difference of the y coordinates, of the x and y coordinates squared, plus add the sum of them and then square root. All right. So square root's not defined. Did you mean something else? Ah, yes, I did, Python. How helpful. So at the very top, we're going to, from math, import star. Now it knows the square root function, as I demonstrated earlier. We will save, run this. Notice that the 3 little greater than, less than signs don't show up. You have to make those show up by clicking on console. And so if I did everything correctly, distance, for example, of, let's say, 1, 0 to 0, 0 should return 1. And it does. Some other points that I know off the top of my head, if it's just one-dimensional, 2, 0 from the origin is 2. From the origin and the point, 1, 1 is the 0. What is that? 2 squared, square root of 2, right? Square root of 2. Yeah, seems to work fine. Questions? No? Okay. That's all. We'll work more with functions later.